I have felt like letting that play until 5:05. We start just a tiny bit early today. So it is the last class. Make sure to send me those extra credit points. I see the question in the chat. Send me those extra credit points. Tell me how many you got. Give me the full total, and that's awesome. Oh no, why sad faces? I know, oh, last class, that's why? No. I am so happy that one, do the TN voice. Jason and I are going to make a separate survey, which we'll send out here in the next coming days. Right, Jason Earl? Right, Jason?
Oh, yes.
He says, oh, yes.
It's happening.
It's happening. Oh, well, you guys can always come by. There'll be donuts again next semester. Thank you to everyone who came by, picked up their tests, got some donuts. We had a great time, and it's been amazing. And I don't know, maybe I can share the links for next semester, and you guys can drop in. Also, we might even, if you remember Julio's interview, which everyone was so happy with, and thank you, Julio, again, we want to maybe have a Stats 1 student or two do an interview next semester and give advice. I already have one or two people who are thinking about it right now, and I might include more people. We could do like a panel. I could have like the different videos up here, and I'd be like, hey, who wants to answer this question? So I'll be like, I'll take it. So if you're thinking about that, thank you so much, Julio. And that looked so cool. Everyone was like, when we asked people, I'll tell Julio this, when we asked people like their favorite things, people were mentioning the Julio interview. There was so many different things people liked about this class and what we've been able to do and what we've brought. So thank you guys and gals very much for being a part of this semester. And let's hop over to our favorite sidekick, Jason, here to see what he has to say.
Hey, it's been awesome just being a part of this class, and I wish you all the best. Have a good holiday season out of school. We're going to miss you all. It's been fun.
Jason has, I can't have done pretty much any of this without Jason because for those who got to see the studio, Jason's been working in the tech industry, or I guess the video production industry, for how many years, Jason?
Probably 20?
20 years. Jason brings with him, he's the brains. Jason is the sidekick. He's the brains. Jason started working in the video industry at the young age of 7. He's now 27.
Yes.
20 years in the industry. And he really, all the stuff with all the lighting, people were surprised at how small the studio is. I'm basically in a small little box. They like that joke. And it's really fun. It's really amazing. And we're always looking to expand. So come talk to us more, especially if you have friends or if you're interested in this. We had some students help us out this semester, right, Jason?
Yes.
So we had students come in and give us ideas and tell us what's going on. So we'll get serious here in a second. But once again, we wanted to thank everyone here. I'll send out another reminder about the TN Voice with the link. Please do the TN Voice. Voice your whole opinion. Tell us what you think. But we want to know what you think about the class, what you liked, what you didn't like. Was my concept? I appreciate that. I was like, let's do a class on YouTube. Yeah, and so Jason actually has other things he does. Like he does a lot for us. And this background you see, this is Jason's background. The intros you see, they're all Jason. I asked Jason for sometimes stuff early in the day. I got better about that. Yeah, and so much better than Zoom. I'm glad you guys like that. You guys, thank you guys. Thank you, Caleb. Thank you, everyone. Thank you, Anna. If you guys can tell I like this. So please fill out the TN Voice. Tell us what you think. It really helps us. Tell us, because the university reads it. So if you don't like the class, fill it out. If you do like the class, fill it out. We want to hear your voice. That's the point of the TN Voice. And let's jump into doing some of your work. Okay, so we're over here on my Pearson. Are you Jason? I am not Jason. So we are over here on my Pearson. Jump into stats. Let's just jump into it. So I was gonna wear that hoodie today. I'll wear that maybe on Saturday, we'll see. I got a Philly D hoodie. So for those who know who Philip DeFranco is. And let's see here. People were asking about, and you know what? We're gonna do a secret reopen. Some people were working really hard last night on chapter 17. You guys got me so excited and so happy right now. We're gonna go over here, we're gonna just do something. Wait, that's not what we wanna do. We wanna go back over here, let's leave that. Where's the button I'm looking for? Let's go over here to the button, and let's go to, I think I need to go to, yeah, it is that. Settings for class. There we go, that's the button. There we go. Does everyone like that? Is that a pro? Is that a good idea? Please remember that is just, so if you're here right now, be thinking after class, if you didn't get a good enough grade on it, we have that reopened right now for you to take a look at. Please, please, please be working on these assignments. These are major important things to be getting decent grades on. I know that they're very tough. I know that they're tough assignments. One thing, someone came to office hours and I had sent them the video, and I always try to help you guys out, being like, here's what you should look at. But take a look at the video that I posted where I do each of the different tests, and I do a 2-sample t-test. So the 2-sample t-test, it's for different, I just reopened it for mine. Last night we didn't have enough done. Sorry, Megan. I just decided, oh no, Megan, it didn't hit your class. I'm sorry. Yeah, there we are. People in the chat saying the video was helpful. The video I'm talking about is, let's see right here. Let me go up to a billion different pages. The video I am talking about, there's our background right there. Do a little self-advertisement right here. So let's go down to the UTK. Oh, look, we're live on YouTube. 45 people watching. Thank you for everyone being here. We're going to do some problems here in a half second. But if we go to videos right here, there's me live on YouTube as we talk. Little inception right there. This video right here, so I'm really going to appear in a video with myself. This video right here, could I like hang out with myself? Oh wait, we got to go full screen.
It's so weird.
I know, right?
Oh.
I could like, wait. We got to do this.
Whoa.
This is the last class.
Oh, wow.
But I go, oh, I'd have to mess up my screen. It's like, Brian,
It's a dream.
get out of here, Brian. What are you doing? Stop doing those stats. What's going on? All right, we're good. Jeez, he's behind me now. His hair doesn't look that good that day. He's improperly lit. It's like he was doing it all himself. I'm kidding. Jason makes everything better. Okay, let's get serious here. In this video, which I sent to students, that's me behind me teaching, I go through and I do the different tests. There's the 1-sample T. Do you see why it's called a 1-sample T? Because it's got 1 T. And then when you notice right here, we go to the 2-sample T. We list out all the notation for the 2-sample T. You don't need to know the degrees of freedom formula. We talk about how to use the applets, and we, of course, do the 2-sample T with the tests and the different formulas. So with this right here, so I could just basically teach this right now, going outside the box. But this is important right here. I think this video is a huge help, and this video is on the Stats1 YouTube channel, so check out this video. Did everyone see it right there? I think this video was a huge help. I go through every single one of those tests, so make sure to go to the hypothesizing test review. I might even chop it up into other stuff right there. So great stuff. Let's hop back and do some of the assignments. I'll take your guys' top 2 questions you have on the review assignments. Sorry, I'm sounding a little hoarse today. How to find the t-values correctly. You know what? Let's find a question that has a t question on review assignment 1. Let's hop in here to review assignment 1. We've had our fun. Let's do a review assignment 1. Okay. This one right here is a confidence interval question. Let's find a t one. Oh, wait. That looks like a t. Okay. So how to do a confidence interval jump. Ooh. Let's do that. This one right here requires us to make a confidence interval in jump. So let's talk about how to make a confidence interval in jump, and let's find it. That's what everyone wants to see. So if we look right here, this is the data button for jump. You only have to do one of them, Serena. Great question. You only have to do one of them. Go right here, copy the data. And remember, this is being recorded, so if you miss a step that I am doing, then go ahead and do this. And so we are having a small issue with my Pearson, which I think I can fix tonight. Sorry about the issues with my Pearson. So does everyone see? We are going to copy the data right here from Jump, or from my Pearson. And with this data now copied, I'm going to go down here to Jump, and we're going to go to Jump, and we're going to open up a new data sheet inside of Jump. The new data sheet is right here. It can be found by New Data Sheet. We're going to make it full screen, nice and big, and so we can see everything. We got all of our data going on. And then let's paste with column names. I want to point something out to you. This blue indicator right here tells you that it is quantitative. If you were to change it, it would drastically change how Jump handles the data, so watch out. You want to make sure this is blue. You'll know you'll have an error if you see something like that. If you notice, it's red now, saying it's categorical because time is in the top thing. That'll change the way it analyzes the data, and that is an error. So make sure to paste with column names for questions like this. Next, go to Analyze, distribution, and double click the variable you want. Go ahead and click OK, and there you are. Now this question is one where you have to remove the outlier, so I'm going to do a trick. I'm going to go here and click the red arrow and click redo, and go, oh there it is over there, and go to automatic recalc. Now anything I do to change the data will automatically recalculate it. But if you notice, I've got my 95% confidence intervals right here next to me. Let's move them away from my head a little bit there. So I am 95% confidence the true amount of time this maze takes, because we're measuring how long a maze takes, is contained in the interval 45.08 seconds to 57.53 seconds. I am 95% confident the true mean time this maze takes is contained in the interval 45.08 seconds to 57.53 seconds. So let's go ahead. I will mention that if you wanted to make different confidence intervals, you can change the level of confidence here by doing a 90, 95. Some questions ask you for different levels of confidence. Let's go ahead and answer that question by putting in the confidence interval. And I can't remember it. It's already jumped out of my head. Put it over here. 45.09 when rounded up. 45.09. I think it was 57.53. I think that was right. Let's check. Good. I was like, I'm gonna get it wrong because I can't remember. Okay, this one's a little tricky right here. We've got different graphics. I'm gonna decrease the font size so we can maybe see them all a little bit better. If you notice, which graphics have the outliers? Only two of these graphics have the outlier that was present in mine. Which two graphics for, let's do some big points right here, which two graphics for 10,000 points have the outlier in it? And I'll move my head so you can see. Which two graphics? Oh, they got it, Jessica, nice job, you are right. Graphics A and B have the outlier. So it's a little bit of a toss-up right here. I'm gonna double click this. I'm gonna double click this and bring it to 105. This makes it look a little more, oh good. I am pretty certain it's A. That looks about like it. If you notice, I double clicked this and I made it to 20 to 100, going by ticks of 5. Great job, everyone in the chat, amazing answers. That is this one right here, and the check button's right behind me, we are correct. This next one's tricky, but you have to know a little bit of theory on how normal quantile plots look. Oh my gosh, thank you, Serena. Thank you, Serena. 10,000 points, Serena, right there. Great suggestion in the chat. Normal, or did I say normal? Yeah, normal quantile plots, QQ plots, also known as normal probability plots. When you get a normal probability plot, it can only go up and to the right. That's the only way the normal probability plots can go. They can be bent, but we can make a normal quantile plot here, and if you notice, it goes up and to the right. Now, there's an interesting feature that might not be as apparent. There is an outlier, and it's being a little hard to see. It's this point right here. It's really hard to see with all those numbers. It looks like it's a dot for the 1.64, but it has to go up and to the right and have an outlier. Now this one right here goes up and to the right, but that is perfect. This one I'm hovering over right now is perfect and is a perfectly normal quantile plot. And it's too good to be true, and our curve does not look that normal. The more normal it is, the straighter it is, and this one has some abnormalities. Hence we see the outlier right there, and we see the little bits of non-normality to it. This is impossible, and this one goes down and to the right, so those are wrong. There we go. So now we've got our conditions. I want to see it in the chat. This is some review right here. Condition 1, I want to see it in the chat. I want to see it in the chat. 10,000 points each one of those answers. I want to see it in chat. I'm seeing it one person. I want to see that chat get flooded with that answer. Let's go back to the classic days where it's just like all over the chat. I'm seeing random throughout the chat. Condition 1 is random. That means each of these rats, because we're doing rats through a maze, need to be randomly selected. And there are no numbers or order to these conditions. I just like to do condition 1 and condition 2 first because they're the ones we use for all of these. Randomly select. Condition 2, and it should say that here. Sometimes my Pearson doesn't mention it, but we need to make sure we sample less than 10%. Now, the reason they probably don't mention that is because this isn't a finite population. By finite population, I mean we can't oversample things like basketball free throws. You can't say, oh, I took too many basketball free throws, because there's infinite. So if you're dealing with an infinite population, you don't have to worry about oversampling. Technically, the mice can run the maze infinite amount of times. There's a theoretical limit, but there's no oversampling because you're just having mice run maze, and the population of mice is near infinite. So I think that's why they didn't mention it here. Now here's where we have to pause. Why do we pause when we get to condition 3? I'd like someone to explain, because we've got other people watching it. Nice job, Eric, in the chat, 10,000. You got the right answer. Why do we pause when we get to condition 3? After we do random, 10%, we stop and we slow our minds and we say, boom, Adriana, another 10,000, and Chase right there, great answers, to see if it is categorical or quantitative. If it's categorical, we will go with success, failure. If it's quantitative, I like Serena's answer right there. If it's quantitative, we will go with nearly normal. So if you notice, we have histograms. By virtue of there being histograms, it is quantitative because a histogram is a univariate quantitative display of data. So this has to be quantitative data. Also, think about it. We're measuring how long a rat takes to run a maze, so that's quantitative. We're seeing how long does it take for the rat to run the maze. That's a quantitative measure of data. So with this right here, the third condition needs to be nearly normal. And the last, there is no last condition. My brain's spinning back up right now. So what do we have right here? Randomization is met. The normal probability plot is relatively straight, with one outlier. Without the outlier, the conditions seem to be met. The histogram is roughly unimodal and symmetric with no outliers. I think we're going for this one right here. I'm always a little bit afraid on these very wordy ones. Try to find the different ones. The normal probability plot is not roughly straight. That's incorrect. It's pretty straight. And when this is straight, that means that the curve is generally normal. Do you know what? Oh, yeah. We'll talk about that right after this question. So I'll do this question, then we'll have it right here. The randomization condition, the normal probability plot is not straight. Okay, so those two right there are good. I think it's between A and B. Are people saying the answer in the chat? No one said the answer in the chat yet. Without the outlier, the condition seems to be met. And then what's the difference between these? Oh, the bottom one is saying it's bimodal. It's not bimodal. Let me look at it again. Nah, it's just the way the bins are. Here's the thing about bin widths. You can get deceived pretty quickly on these because if you look, that looks unimodal right there. But if you change the bin widths, it can change the way it looks. This is going back to the first exam, that bin widths drastically alter the way it looks. And in truth, it's probably really got one mode. I don't think that's a second mode. That's kind of a edge of that second mountain right there. In truth, if I were to visualize this, I don't know, that's fine and that's fine. It's kind of between those two, but those are the two visualizations. People are saying B, we're gonna do it, we're gonna go for B. And did we get it? Oh, we got it, of course, we got it. Eliminate the outlier and do the confidence interval again. Here's the trick I did. Do you remember when I said I was gonna go here and go to automatic recalc? By doing automatic recalc, we can click on the point, which I've already done, but make sure you have your pointer tool selected. Click on said point, then go up here and go to rows, hide and exclude. Now watch the numbers closely. Watch the numbers behind my head, and they change. The outlier has now been removed and automatically recalculated. For this to work, you have to have automatic recalc on. You will know it's worked if you see things like the maximum change. Now watch out, it will remove the point from the plot no matter what, but if you see the numbers change, you have automatic recalc on. There you go. Yep, there we go. It's a little hand tool. You just do the hand up, do the hand down. So now we have 44.43, and there we go. I think I've got it in my head. 44.43, and was it 53.22? Was that it? Oh no, that was a guess. That was a guess. It's right. I just copied it wrong. 54. Did I type 53? Oh, come on. Someone's going to post that and be like, he got it wrong. I just didn't copy the numbers correctly. I was trying to put them in my head. It's more fun if you try to put them in your head and then not look back, but then you get it wrong. Don't do that. Don't do that. Copy them verbatim. How do you turn on automatic recalc? Amazing question, Morgan, for 10,000 points. Thank you for asking. It's the top red arrow, and it's right here under redo. Automatic recalc is right there. All the graphics and stuff have automatic recalc. Carolyn, 10,000 points for helping answering the question too. I love it when you guys help each other out. So thank you very much. Does the test meet the requirement of taking at least a minute? And the answer is no. I am 95% confident the true mean time it takes the rats to run these mazes is contained in the interval 44.43 seconds to 54.22. I ask you to try to do things like interpreting confidence intervals like that. 60 is not in the interval. What does that mean we can do to 60? If I were to test 60, I could what it? If I were to test 60, I could do what with that value? Like, let's say hypothetically I were to go over here and I were to say, let's test 60. I would know that the p-value on the two-tailed test would definitely be below 0.05. And watch, it'll be behind my head, that the p-value on the two-tailed test is below 0.05. And we got such an interesting one, because look at the p-values. This one is 0.00001, and that makes this one 0.99999. And then this one right here is double. 0.00001 would be the area below the curve on this line. And you can actually see it, we can visualize it on the animations right here. That very, very, very tiny 0.00001 is the area below the line. So if I go to the left side, it's that little tiny area you can't see. But above it is the area there, and that's the area above that line. And it's really hard to see, but the two-tailed test is double the smaller one. And there's decimals we're not seeing in the background. But the low side, double it to get the two-tailed test. The low side, take 1 minus it to get the right-tailed test. And that's where these p-values are coming from right here. You don't see it all shaded in, or the whole graphic will be shaded. Can I do question 2? Why not? Let's do question 2. So question 2, is it this one right here, or the teenage girls one? We can't do this one in jump. Well, we'll do it in, I got my pen, so we're good to go. So let's do this one right here, and we'll take another question or two. Hello, with Pearson, if you get a p-value of 0.01, ask for just write that. Serena, another 10,000. Thank you for your help, Serena. Great answers. We got condition 1 here, random. Condition 2 here, 10%. Now, condition 3 is a tricky one. Condition 3 for this is going to be, there's project 3. Not project 3, condition 3. You're cracking me up, Kale. 10,000 points right there. We'll do the hot dogs one next here. All right, so we got condition 1, random. Condition 2, less than 10%. That's right, 10%. Condition 3, success, failure. But this is a statistical test. Great job, Adriana, right there, another 10,000. Keep up these answers in the chat. It's going to be n p naught, n q naught greater than or equal to 10. It doesn't truthfully matter if it's exactly equal to 10, and we won't do that on the test. We're not going to be like, oh, it's on the borderline, because it wouldn't make that big of a deal if it's on borderline. But let's see here, what is n? N is sample size, and p naught is the hypothesized proportion. So whenever you get a question, let's get very test specific here. Whenever you get a question, identify what the numbers are. 1991, that's the year. That doesn't matter to us. And then we have 3.91. Who in the chat for 10,000 points can tell me what 3.91 is? Here's the hints. We're going to see if the teenage mothers have the same rate of births as this statistic right here. And the right answer is, there's 2 answers on the board, and one of them is right. What is it? This is the one we're gonna use as a possible value. So which one is it? I've only seen one answer in the chat. I want to see if you guys get it. TEE, thank you, TEE. TEE gets 1 billion points. You are so awesome. P-hat is there. People are solving P-hat. People are solving P-naught. This is P-naught. What I've highlighted, and you might be wondering, why does my Pearson not highlight it? It's because it's a dynamic number that can change. For some reason, it won't highlight when you do it. But that is P-naught. That is the hypothesize. Be very careful. This is what we are going to hypothesize. And now we have to see what is P-hat. So that is P-naught. If you want to solve to see if you meet the conditions, you need to take 0.039 times, and then the sample size. And the sample size, where was that sample size at again? The sample size was 461. That is the sample size. And so I'm going to close off this document here so I can open them up like that. There we go. And it was 461. And this is equal to, we've got to pull up our calculator now. 461 times 0.39, and that is equal to 17. We're going to round that to 18 to be nice. And then guess what? We have to go here. What value am I writing down right now for 10,000 points? This value that I am writing down, that I am solving for in my head, is what? What value did Brian just write? That 0.961. What value did Brian just write down? I'm doing all this right here. What value did, you guys are getting it, you're getting it. I'm writing down n q naught. I did switch my n and my q naught. How did I find q naught? Q naught is 1 minus p naught. So q naught is 1 minus p naught. So I always do 1 minus, if I was doing this on the test, I'd definitely double check my work to make sure I got the right number. But q naught is 1 minus p naught. Amazing job in the chat. Keep those answers coming. That's what we want to see. You know what? We're going to solve this one in our head too. You know why? Because if we know p naught, we can solve for q naught. I'm totally going to make a mistake now because I'm saying I can do it. I believe it's that. Let's check our work. Let's talk about the relationship that p naught and q naught have to each other. Well, they're complements. So when we do this equation right here, this is how many successes we expect, and this is how many failures we expect. These two numbers right here, if you add them up, they would equal what? What's that magic number right there? It's how many successes I expect in my sample and how many failures I expect in my sample. So that's n. So all I did was subtract from 461. I subtracted 18 from 461. Now, do we meet the success failure condition? The answer is yes. And these are important test type questions where we could say, is the success failure condition met? And it is met because there is at least 10 successes and at least 10 failures. So both these numbers being greater than or equal to 10, great job, great job. We passed both. We passed the success failure condition. What I would do if I was working this problem right now, I would change all my things up top apparently. What I would do is I would go and I would start writing down my notation. My notation, we'll go with a nice blue right here, would be that p naught is equal to 0.039. Make sure you know what p naught is. P naught is the hypothesized proportion. I would then go and I'd write down n equals 461. I would also write down that x is the number of successes in the sample. X being the number of successes in the sample was exactly 15. Do you see how there were 15 twins born to 461 teenage moms? So we go back to here and we write 15. I need your guys' help in the chat. What are we going to find next that we know n and x? We know n, we know x. What will we find next? We know n, we know x. We need to find what? I want to see it in the chat first. P hat, you're right on track. 10,000 points. Keep it up. P hat equals x over n. Great job. Keep writing in the chat. Remember these things. P hat equals x over n. You guys crack me up in the chat. We will find that standard error here in a moment. But we have this 15 over 461 equals. Let's find that out. What is that? Oh, I was going to do it in my head, but I don't want to. There we go. That is the sample proportion, 0.03254. 0.03254. Hopefully I didn't do anything all crazy. Oop, there we go. Cool. 0.03254 is the sample proportion. Now, see, exactly. Refresh the page, use Control R or Command R, refresh the page, be right on track with us. Yeah, sometimes if you just hit refresh in the top window, it'll keep you a little more live, like you might be a second or two behind. And I might also see stuff because I'm the channel owner, just in case something crazy would be in the chat, they might let me see things like a second or two earlier than you guys. So, I believe we're doing a statistical test right here. I have this in my last video, but what are the 3 things we will do to do a statistical test? What are the 3 things we will do to do a statistical test? The 3 things we will do, the first thing, oh, you missed a 0 after that decimal? Oh my gosh, are you one of ours? Oh yeah, Rana, you are. Rana, 100,000 points, major error. Let me undo all those spaces I just did. Sorry about that. Ooh, that is a big error. Nice job. Small but large error. Great catch. So right there, that is it right there. Double check your calculator. Easy to make a little typo. So now what are we going to do? We're going to use a formula right. Oh, I asked, what are the steps for doing a hypothesis test? Step number 1. Step number 1, let's open a new sheet right here, is hypothesis testing the null and the alternative. So we're going to do right here the null and alternative, HO, HA. What am I testing? I'm testing. Great job, Jennifer and Taylor and everyone else in the chat. 10,000 points if you gave that answer right there. We're going to test the null and the alternative. Now let's do something to help us out right here. The null always has the what sign? The null, I'm going to see in the chat in a moment, I know, because I know you guys know this. The null has the equal sign. The null has the equal sign. What are we testing right here? We're going to test the proportion of births for teenage mothers. The proportion of births for teenage mothers that result in a twin. So what do we need right here? Nice job right there with the equal signs. We're going to test P, and if I write P right here, that means this is P. Do you guys remember what goes over here? What goes over here is P naught, and P naught, we might have to look back at our cheat sheet, but P naught is going to be 0.039. 0.039 is P naught. Oops. 0.039. We're one step away right now from having our null and alternative. Now all we have to do is put the correct sign. The question asks, is it the same for teenage mothers? Is it the same for teenage mothers? So if we want to see if it's the same for teenage mothers, Adriana, another 10,000, keep it up. Not equals right there, not equals everyone else 10,000. Keep these answers coming in the chat. This is practice, this is to make sure we have it. I want you to look at something right here. These values in boxes 1 and boxes 3 will be the same. This value in the green box will never change. You will always put the equal sign when writing the null. The null has the equal sign. Then when you pick your first thing, it needs to be a parameter. The thing I have in box 1 is a parameter, like the true proportion. I want to know if the true proportion of teenage mother births that results in twins is equal to 0.039, if that is the true proportion. So let's read it. The null states that the true proportion of teenage mother births that result in twins is equal to 0.039. The alternative states that the true proportion of teenage mother births that results in twins is not equal to 0.039. So that means we've written it correctly if we can read it as a sentence. Now we have step 2. Step 2 is going to be to solve the equation. Let's solve the equation. Now you are given all of your equations on the test, so do not worry. You get all of your test equations. So I need to make new sheets all the time. Let's go right here and write P hat minus P naught over P naught Q naught n square root. That is equal to a z-score. Look at the similarity to this. It's merely observation minus mean over standard deviation. Just look at similarities. Observation minus mean over standard deviation. Same sort of idea going on here with this formula. And now let's go ahead and solve it. We need to take our P naught and let's do P hat first. Okay, let's grab that value. What was P hat again? Was in the calculator? Yes. 0.03254. 0.03254. That one off the rails. 54. Minus 0.039 over square root, it's going to equal that C, 0.039 times 0.961 over 461. I think it was 461. We'll check here in a second. 461. So we're going to solve this equation right here. Sorry, my handwriting is not the best. Double check your work. Double check your writing. There's a 5 right there. So, and I'll move my head out of the way. Let's scroll it up a little bit. Oh, there we go. So there is the equation right there. Make sure you can read your own handwriting. Make sure you have the equation solved out. And the sample size was 461, I believe. We have all our notation right there. We are good. Let's go to the calculator and find the z-score. This is step 2 in solving your problem. 0.03254 minus 0.039. That is that difference right there. So there's the difference between the two. So now we need to take that difference and we're going to divide it by the following number. Times 0.961 divided by 4.61. And then we're going to square root this. That is the bottom of the equation. That is the bottom of the equation. Oh, did everyone solve it? Is that it? Oh, you guys are excellent. Yeah, amazing work. 10,000 points. Great job. Thank you for working the problem with me. That means you're getting it. That means you're solving it. Great job. I'll just look at the chat for the answer. You guys are right. That is the z-score. So that is step 2. We've done half the steps. We're almost done. Now tell me, does this z-score look very large? Does this z-score look very large? Does that z-score look very large? Does not to me. That's not a very large z-score. What we're going to do now is we're going to draw out our curve. We're going to pretend this is the test. We're going to pretend we don't have the David M. Lane calculator. It could say something like draw out the curve and show what your z-score looks like. Well, we're going to draw our curve right here. We go 0, 1, 2, 3, -1, -2, -3. And then we go right here, and we're going to plot our z-score. And our z-score is right there. There we go. There we go. There's our z-score. That's our z-score right there, and then we're going to do this. Why did I do that? Why did I just reflect it on the other side? Why did I just reflect my z-score on the other side? What just happened? Why did I just reflect my z-score? Two-tailed test. Does not equals alternative. Two-tailed test, plot both sides. If it says greater than, plot to the right. If it says less than, plot to the left. I'm mirror image, so I have to be careful which way I point. And then if it says does not equals, plot both sides, so you have to reflect it on the other side. You have to take it and reflect it on the other side. Remember, if it's greater than, shade to the right. If it's less than, shade to the left. And if it's two-tailed, shade both sides. Will you be the same amount of time on the other test? Yes, you will. I think it's 2 hours, actually. I'm 99% sure it's 2 hours, Hannah. So that's an extra 30 minutes. But I will say this, people are actually quicker on this test. People actually, I've seen people solve this in like 30, 40 minutes, and I'm like, you sure? And they're like, yeah, I'm done. And they do well. It all depends. Oh, we already know what's going on. I like seeing that in the chat. Because look at that p-value. That p-value is crazy. It's probably going to be, I'm going to put my guess on here. I'm going to put a guess. This is just a guess. It's just a guess. We're saying it's about equal to. I'm going to say the p-value is about equal to 0.0457. There we go. That's my guess. That's my guess. That's my guess when I get really wrong here. It's a pretty decent educated guess from what I know about this, but let's take a look right here. We need to now, I'm going to bring this up over here. Let's bring up our favorite site, Mr. David M. Lane. And let's take David M. Lane, bring it down over here. We've got so many tabs open now. There we go. So that z-score was, let's take a look at that z-score. Z-score was -7.16. So we need to plot like my curve looks, and we need to go to the outside, -0.716. Oh, wait, how close was I? 0.474. How close was I? Ah, so close. 0.474. Probably wouldn't have gotten it on my Pearson, but we got pretty close. That was a decent guess. I said about 45%, it was closer to 47%. So that is the p-value right there for the area under the curve. Here's the thing, when you make your graphic, and this is how I ask you to like practice this, when you draw your graphic, go and look at my Pearson and be like, does that look anything like what I just drew? Does this curve right here look at all like what I just drew right there? Do you see similarities between the two curves? Does that look about the same? I do too. I see the similarities. Let's move it all around the screen. My curve's not as nice and neat, but that's the important thing, is that when you draw it out, you're like, yeah, that's a pretty big p-value. And as Adriana pointed out, we're going to fail to reject the null. I do not have evidence which states that the teenage mother bursts are different from 0.04 or 0.036 right there. But great job. This is awesome. So now we've done the whole problem. I want you to notice that we basically solved the whole problem right here, as long as I don't make an error. We've got the does not equals alternative right here. We've got to find the z-score, and the z-score was -0.716. Oh, did I want 2 decimals? I literally saw that at the last second. Darn you, my Pearson, I'd put more decimals. We've all done that. And then this says 3 decimals, and that was the p-value obtained from right here. So that p-value is 0.474. And then we're definitely not rejecting the null. Fail to reject is the only one that meets that criteria. And we got it. I want you guys to notice something. We did not follow through the question. All we did did the 4 steps to see if we knew how to do the test. And by doing those 4 steps, 1, write the null and alternative. 2, check your conditions and find the z-score. 3, find the p-value. 4, reject the null or fail to reject the null. And I think there's some great questions about chi-squareds. We're going to hop over to chi-squared question because I really like it. We did a confidence interval, and then we did a test to show how a few of those can be done, starting out right here. Virus threat protection behind me. So let's do a chi-squared. Okay, let's do that. Let's do a chi-squared test. Okay, chapter 19 homework quiz. Wait. Oh, is there a question? Ask a question in chat. We only have to do 1 review of the assignment. Yes, that is 100% correct. You only have to do 1 review assignment. The t-statistic on the hot dog question. Yes, you asked that earlier. Let's do that one. The t-statistic on the hot dog one. Let's do that one. Here we go. Is it preview? Okay. The t-statistic on the hot dog one. What is the hot dog question? Here we are. We're right here. So the null has to have the equal sign. And we're trying to see if the sodium content has gone down in this question. And then we need the t-statistic. Cool stuff. Let's do it. So with this t-statistic, we need to know the equation. Let's get the equation going up here. To get the t-statistic, the following equation will be used. We need to go and do t with n minus 1 degrees of freedom. Now that's subscript. Don't multiply things out with that. That's subscript. Now we go y bar 1, or y bar, sorry, I didn't write the 1. My brain said, what did you just say? I'm thinking 2 sample t. There we go. We got it. We now have the formula for the t-statistic, but now we need to identify what everything is in the problem. So now we're going to go and look at the problem and identify y bar. What is y bar? I need to find something that says what for define y bar. What is y bar again? Y bar's got to be something. I don't know. Sample mean, Maddie, 10,000 points right there. Y bar is that sample mean. Make sure, and it's good to put mean, but put sample mean and you know exactly what you're looking for. Let's see if the question says something, yada, yada, yada. Wait, sample. Wait, the mean of the sample. That looks like y bar to me. Well, everything I just highlighted. And then we have here, still talking about the sample, that the standard deviation of the sample was 18. So if the standard deviation of the sample, those are some easier numbers to remember, we have y bar equals 322.3, and S is sample standard deviation, and N is 40 hot dogs. And then we are testing. Does everyone see how that has that little knot there again? We are testing the value of 325. That is a 325 right by my head. So we're testing the value of 325. So we have all the stuff written out right here to solve it. And does this make sense right here? We will get points taken off if we do not use the subscript. Oh, you're fine. It's just, this will be a T with, you don't know. At the end, usually we don't include the subscript. It's just used for the curve. Great question, 10,000 points. You won't need to put that, like when you solve the T, you won't have to be like 22.1 with 39 degrees of freedom. You'll just say the T was 2.1. You're welcome. Do you want me to solve the rest of it? Are you pretty good from here? Do you know how to identify your notation? Then you'll take the T. Once you get the T, you'll find the what from it. You'll find the p-value. Once you find the p-value, that was step 3. You'll then reject or fail to reject the null. Those are our only 2 options. But remember, write your null and alternative, which was the first thing it had you do. Find your t, find your z, find your chi-squared, and then find your p-value, step 3. And then step 4, reject or fail to reject the null. Do you want me to continue on, or do you think you're good? I'm more than happy to, but I think you guys got it. I think that maybe gets everyone over the bridge. And thank you so much. Great questions. I love it when you guys are like, I just need this one question to get it figured out. And then you're like, I got it. If you want me to do more, I'll definitely do it. We good? Or, because from here, it's pretty much solve. And then, like, let's say, I'm going to cough there. Let's say not real. Not real. As in, we are going to maybe step 3, the p-value. Let's do that real quick. Let's do the real. So now what we need to do is we need to take these values, we need to plug them in. So we do observation. This is always the observed value. Once again, this formula is simply observation minus mean over standard deviation, basically. You're just standardizing a difference. If you notice, it's just a difference standardized. Continue, okay, they're saying continue in the chat. So we will definitely continue. We got enough votes on the continue right there. And what is my t-statistic, chat? What is my t-statistic? What is the t? Guys, double check my work. Make sure I get it right. Observation minus mean. Oh, well. When you solve on these calculators, it's easier to get the bottom solved first because I'm not writing things down. 40 square root is that. Divide by 18 is that. And then it was negative 2.2. So here we'll just do the top again. There's that. Divide by the bottom. There's that. Oh, wait, that's almost the same answer as last time. That's so similar. Oh, no, no, no. Oh, my gosh, what is going on with me? Wow. Okay. Whoa. 10,000 points, Madeline. Wow, I cannot write today. What is going on? I'm trying to see if people are paying attention. I'm like, are you guys paying attention? Do you notice these little typos I'm making? Madeline, that was a 100,000 point answer. So thank you for noticing that. Oh, and Kate noticed it too. Kate and Madeline, thank you everyone in the chat. Now we've got the right answer. It's so easy to copy things down wrong. I will say this, if you make a copy error on the test, it's usually just 1 point. I've lost 2 points today. So negative 0.949, is it rounded? Negative 949. That is our answer right here for the t-statistic. And we should also write down that the df, what is my degrees of freedom equal to? That is the t. So that is t. What are my df for this? What are my degrees of freedom? Does anyone have any idea what the degrees of freedom are for this? What are the degrees of freedom? 39, you are right, because the sample size was 40. So now what we're going to do is we're going to go here, and we're going to go to stat distributions. Stat distributions. And I will say this, I get worried sometimes. I'll often take these numbers and put them in as long as I can. And see, I'm worried about this one. Sometimes decimals get weird. If you want to make sure you're getting all of the exact, and I'll drop it in the chat. I have a favorite t-calculator. I'll drop this in the chat. Here is the ultimate t-calculator for all your decimal needs. So we're going to put in 39 degrees of freedom. There's the t-curve. We're going to put in our t-value with every single decimal, and we're going to plot below it, and there's the answer. So this one is the Iowa Applet by Matt Bogner. It can carry all the decimals. It can do everything. Taven, we're going to do that. Chi-squared next, you got it. So there's the applet I'm currently using. It's probably one of the best t-applets out there, and all I did was graph the area below my t-score. Because this is a less than test, you might say, Brian, how'd you know to graph less than it? Reason being is we are doing a less than test. I want to point something out right here. The value in this spot right here is what? The value in this spot right here is what? What is 325? What will always go in this spot? It's the hypothesized value. In this question, what is this? What is ever in this spot must be what? And it's in both spots. It'll be the same number. Who knows in the chat for 10,000? That is mu naught. You got it right. That is mu naught. You guys know what we're talking about. That is mu naught. And previously in the other problem, it was p naught. So it can help you show which thing you're trying to hypothesize is true. Make sure you know what is going in each spot. The answer to this one is negative 9.5. So afraid I'm going to make a typo again. The p-value, I think I saw was about 17%. Was it 17.1? Let's find out. It was 17.4. And it is a less than test. It's always like click and you're like, yes, I got it. Woo! Okay, here we go. We haven't done this in a while. How do we know to reject or fail to reject the null? When the p-value is high, just let the null fly. Just let it be. When the p-value is low, reject the null. So our p-value is higher than alpha. That's what I mean by high. When the p-value is higher than alpha, you do not have evidence. Let it fly. Don't do anything to it. Just let it be. When the p-value is low, you reject the null. And what do we mean by below? We mean lower than alpha. There we go. Just let it be. Don't do anything to that null. Don't reject it. And the biggest thing, I think that's why I like to say when p-value is high, just let it fly. You're not going to accept it. You're just going to say, well, that's believable. And we do not reject. There is not evidence that that the mean sodium content was less than, because that was the alternative we were testing. Choose the right condition. Oh, people love this one lately. And the question is, will a larger sample size ensure that regulations are met? No, they're trying to get a sodium content below this amount. So it's not like if you take more samples that you'll meet the requirement. You'll just get a better estimate. No, don't worry. A lot of people have asked about this one. They're like, wait, what? Why? If you get a larger content or larger sample, the mean will just be better estimated. It doesn't mean you will meet the requirements. So really great one right there. Which of these is not properly formatted? That one. We got it. Here we go. What is the name of the difference between the null and the true population parameter? That's effect size. What is the name for the threshold? That's alpha. What is the probability that a test correctly rejects? That's the power of a test. What type of error is made when the true null is rejected? Ooh, I like this. When the null is true and we reject it. If the null is true and we reject it. Type 1, you guys know that. If the null is true and we reject it, type 1 error. There we go. I think I completed the other ones. If I had just not closed the assignment, man, I would have had those other questions. I would have been done. I'd had it done. I know, right? Make sure to know these things. I want to point something out. Could you just blindly go to this question and just be like, I don't know, and then you go down here. I got to actually look now. You go and you're like, oh, I got it wrong. Let me try again. Oh, it's type 1. I got it. Yes, you could do that. Well, so if you don't do the assignments and you miss these questions, oh no, you can just guess. But someone's going to cut that. Luckily, I have my eyes covered. People wouldn't think I was actually trying seriously. But yeah, on the test, you have to know, but not on the test. Bethlehem, you get 10,000 points right there. You're pointing it out. Know what these things are. And we got a really great way for those who haven't seen it to memorize type 1, type 2 error. In a type 1 error, practice this with us right now, all Stats 1 students who are watching. In a type 1 error, the null is what? What in the world is going on right here? You don't have to do the second one. It's just an extra. If you've already finished both of them. I agree. In a type 1, the null is true. Now, what would be an error if the null is true? If the null is true, it's going to be an error to what it? In a type 1, the null is true. And look at that. It's going to be rejected. That's an error. If the null is true, you should not reject it. In a type 2, the null is, what does that look like? That looks like an F for respect. Type 2, the null is false, and we fail to reject it. Because if the null is false, you should reject it. So if we make a type 2 error, the null was false, and we made an error because we failed to reject it. I think there might have been some questions in the chat too. I saw stuff about alpha. Feel free to ask. We're going to do a chi-squared one here next, but this has been pretty good review, just doing different questions and concepts. Please ask questions if you got them in the chat. But you got it, Anna, right there, 10,000. Type 2, null is false, and you fail to reject it. That is an error, because if the null is false, you should reject it. The null being false should be rejected, but the error is so when the null is false, there's your first F, you fail to reject it. Here are the two Fs. When the null is false, you fail to reject it. That is a type 2 error, and you hear your two Fs in a type 2 error. So good ways to memorize it and to keep it in your head. It's very easy to flip them back and forth. I'll say this. One of the first questions I ever got wrong, or was basically people thought I got wrong, which I guess I maybe got wrong, was a type 1, type 2 error question when I was teaching. And a student was like, wait, you said this. And I was like, oh, I reversed it. It's so easy to reverse because why is it type 1? It's just what they came up with. They're calling it a type 1 for this, but you just have to understand that a type 1 is when the null is true, and it's an error to reject it. Type 2 is when the null is false, and we fail to reject it. Very good way to do it. Can you say what power is again? Good question. Let's talk power here for a moment, then we'll do chi-squared next. Thank you, Jackson, for the great question right there. 10,000 points. Throwing out the big points today. Here we go with what power is. So power is the ability to correctly reject the false null. Well, that's like a stat book definition right there. Power, in my mind, is the ability to find results. So I want you to think of what would be a powerful test if you went to the doctor. You go to the doctor and you want to know if you're sick. I'm like, oh no, I wonder if I'm getting sick. My throat's a little sore. And you go into the doctor and the doctor just looks at you and he says, you're not sick. So you're like, I don't know. I need a doctor who goes, more powerful test. You go to another doctor and she decides to take a vial of blood. Which of those sounds to be a more powerful test? The just looking at you or the blood test? Just by what we understand, you understand that it's the blood test. You're like, well, why is the blood test more powerful? It'd be because they're getting more data. So what controls power? One of the first things right here would be sample size. Sample size going up increases power. It's so weird. It changes colors on me. It's color changing pens. Sample size goes up, increases power. So let's do this. Sample size up, power goes up. This is the literal idea that if you were to go to the doctor, would it be easier for them to tell if you're sick if they took 1 vial of blood or 10 vials of blood? Oh no, color changing. I like that. 1 vial of blood or 10? 10. 10's easier. It's more powerful. They'd be better able to detect if you're sick. And so that's a larger sample size. And I see people talking about effect size in the chat. Yes, you're right. How does effect size work when you're sick? Effect size is the difference between the null and the truth. Well, the null here is that you're healthy. And the alternative is that you're sick. So if it's true that you're sick, imagine you're only a little sick. If you're only a little sick and you're like, Adrian's right, you can't control it. Hopefully you can't control how sick I am. So if I'm only a tiny bit sick, would it be easy to detect? Would it be easy to detect if Brian's just got a little bit of a cough? Would you be like, ooh, he's looking sick, that's a problem? No. So what happens when you turn up the effect size on sickness? When you turn up the effect size on sickness, what happens to Brian as the effect size? The difference between him being healthy and sick becomes more obvious. As that effect gets bigger, what happens to Brian? Oh no, we're going to hear horrible things in the chat. Hopefully not. Power does increase, but what happens to Brian? What would you notice about Brian as there's a bigger effect size? With a bigger effect size, Brian would be passed out. He'd be sweating. He'd have a fever. You'd be like, what is wrong with Brian? He'd be like, he's fine. You'd be like, no, there's something wrong with Brian right there. An effect size is an easier thing to notice. The larger the effect size, the more powerful the test. Oh no, I'm gonna cough now. It's power of mental thought. Last but not least, we have alpha. Alpha is the rejection criteria. And if you increase alpha, you increase power. I know, I should have got my flu shot. So with any of these, we increase sample size, we increase effect size, we increase alpha, we increase power. What is the most powerful test you could use is a test with an alpha of 1. Because alpha is how much you'll make a type 1 error. A type 1 error is normally made what percent of the time for 10,000 points? What percent of the time do we usually reject the null when the null is true? Usually alpha is set equal to, by default, equal to, one here in the chat, 0.05, you got it. That is default alpha. But what if you turn alpha all the way up? You'll never make a type 2 error, you'll only make a what error? If you turn alpha all the way up, you'll only make a type 1 error. So the higher the alpha, the less type 2 errors you get. You might say, Brian, why are you talking about type 2 errors? Because if you increase any of these, you decrease beta. Beta is used in the formula for power. Power is 1 minus beta. Thus, all of these up there make beta go down. When alpha goes up, beta goes down. When effect size goes up, beta goes down. When n goes up, beta goes down. And if beta goes down, power goes up because power is the inverse of beta. Power is not making a type 2 error. Power, when we used to talk about probability, is everything but making a type 2 error. As in, you find results if results exist. You don't make the error where you fail to reject the null when you should. So power is the ability to find results. Did that click for anybody right there? That power is not making a type 2 error. It's finding results when results exist. Because if you make a type 2 error, you fail to find the results, and power is the ability to find the results. So you don't want a large beta. I hope that helps. Now I'm sick. But I hope that helps better explain what's going on here with power and the three things that control power. Did that help out a little bit? I hope in the chat. We're gonna do some chi-squared stuff here right now, but chi-squared time. How's chi-squared sound, or any questions in the chat? Absolutely, like hearing that in the chat right there. Good stuff, good review of power. And we're gonna send out some more stuff on review here later tonight. Should we do a, my brain's broken. Should we do a chapter 19 or let's do a chapter 19, because everyone's got chapter 19. So anyone else is gonna watch this video, let's do a chapter 19. Is there a specific chi-squared question people wanna see? Is there a specific chi-squared question people want to see done? What chi-squared question shall we do? You pick the chi-square. The one where we can cheat and jump. You can cheat and jump in so many of these. Number four. Actually, you know what I need to do? I need to go to replace questions, then I can see all the questions, every question. Here we go. Let's do it. There are 10 total questions. Number 4 question has to be right here. Are you thinking about this one? Ooh, it's a long one. Are you thinking about this question right here? Do you remember any of the start of it? If you guys just tell me to look at this question. I've done this one a lot. We were doing this one during office hours today. This one can be done in JMP. Let's show how this can be done in JMP. One, when you bring data into JMP, it has to be formatted correctly. Copy to clipboard. We're going to copy it. We're going to bring it in. We're going to go over here to JMP, and we're going to set a new worksheet. So, yep, this one, you might have to calculate chi-squared in this one. This one will also show how to do all the chi-squareds. Big thing, when you paste your data, that is incorrect. Watch out. If you did this, you've done it incorrectly. Start over, and we need to go here, and we need to go to Edit, Paste with Column Names. There we go. The data has now been correctly pasted into JMP. We can change this right here to response if we want. Makes it look nice. And now it's not Excel, you can't double click. And let's go right here and let's go to tables and stack. Remember, this is being recorded so you can watch how to do this again. Now you'll stack the blue ones. Stack the blue ones. Click OK. You now have the proper format. Look at how it looks. Yes, yes, no, no, male, female. These are the counts, as in, there were 386 males who responded yes, 295 females who responded yes, and all the numbers below. So now we can analyze this data properly. Let's go here and go to Analyze, Fit Y by X. Oh no, Cindy, so good to have you in real time with us now. We're going to put the label here in the X and response here in the Y. This can change how some questions looks, but will not change the chi-squared calculations. We're going to put frequency over here in the data. Please note this structure if the data is structured like this. This is the proper structure. The red ones go here. And I want you to notice also 2 red things make a contingency table. And that is how we get our mosaic plot and contingency table. Cool. So now we can cheat. We can go over here and we can change these, which this often might look like your test output. I'm going to look down here at this. I try to look up at your guys' screen. Let's do, oops, deviation. We don't want the deviation. We want the expected and the cell chi-squared. Okay, so now that we have all of this data right here, let's take a look at what we got. We have the counts, which are what you saw in the output, like the 386. You now see the male 386 yes is right there. Then we also have the expecteds. Who in the chat for 10,000 points can tell me the formula to get the expected count of males yes? Please look at the cell I'm hovering over and let's practice on how to do this. I really like showing this off because I think it's a very kind of easy trick to do. I know I'm covering it up, and I'm going to bring it over here so I can actually draw on it. The expected formula, I beg people to write it on their test. It's the following. Oh, people are writing the formula already. Great job. If we want to do the expected formula, we take row total times column total over grand total. There it is. Look at where this points to. It points to this cell. Someone tell me the exact number this would solve to. Who knows exactly what this formula will solve to? What would, if I solve this out mathematically, what will I get? Everyone's nice job in the chat right there. You are right. And also we can see here, if we do another one, the formula, all I'm doing is going to circle this one. What is this, the expected, this formula right here, where it's 1,493 times 1,672 over 2,174, that is the expected count for what? That is, nice job in the chat, 10,000 points for those answers. That is the expected count for females who said no. Amazing job. Always look to where it points to. What the cell it points to is the cell it's solving for. So this is the expected count right here. We can also do some other formulas right here. It's good to practice these formulas. We can also do these two numbers right here, like 295 minus 523.8. We'll just round it up. I'm running out of room. There we go, over 523.8. All this is the formula observed minus expected squared over expected. What does that solve to? Observed minus expected squared over expected solves out to what? Like what am I solving for right here? The observed minus expected squared is all of these cell chi-squareds. Know how to practice these formulas, know how to do this. These are all the cell chi-squareds. Nice job in the chat, another 10,000 points. Keep those answers coming, keep practicing. That's what we're here to do, and we're understanding how to write this out. Now I want to make something very, very clear with these questions. One of my favorite things to do is when we start one of these questions to know how to write the null and the alternative. Look at the variables. We have somebody's status and somebody's gender. We're looking at newspaper headlines, traditional wisdom, a sinking ship. So someone's status on a ship. Oh, they literally tell you the null alternative. Well, I mean, they make it obvious. We would have the null and the alternative being, and all we do is we say the words between it, somebody's gender is independent of their survival. Somebody's gender is not independent. So when we do this null alternative right here, we would say first that survival was independent of gender, and then association means that they're not independent. Sometimes my person likes to switch the words. If I was writing this, I would write it on the test. Survival was independent of gender. Survival was not independent of gender. That's how we do it right there. Did I know? Oh, this is a full quiz question. That's no fun. I don't get to see my answers. Are the conditions for the inference satisfied? Pretty much yes right here. Well, we have everything. Is it going to say because they're not random? We should have yes because the data are counts. That is condition 4. The data in the groups are independent, and the groups have at least 5 observations. We don't want them to be dependent. No. We don't want that, so yes. The data group are independent. There's at least one group that has at least 5 observations. Yes, we want them to have at least 5 observations. We do not want them, they're definitely counts. What does count data mean? If you're wondering what is the condition count data means that we have 2 categorical variables. Living or dying on the ship is categorical, and gender is categorical. Calculate the chi-squared test statistic. Well, we cheated. We cheated and we got it via jump. We could do it by hand, but it would just take a while. It wouldn't take too long. It'd take 10 minutes. It's just busy work. I mean, it's practicing knowing the formula. Oh my gosh. 630? Oh my gosh. I don't even need to, wait, that's not the p-value. That's the chi-squared test statistic. 2 decimals, it's 630. It doesn't matter what the decimals are. That's ridiculous. That is such a large chi-squared test statistic that the p-value is obviously 0. And then it's 0.02. Really, it wants those last decimals. It's so crazy that it, wait, that's 0.02. Where's my O? There we go. The p-value has to be around 0, and that means we would reject the null. Oh, there's my extra 0. Wow. I'm just throwing extra zeros everywhere. Interpret this. Well, we are definitely going to reject the null. Thank you, Colin. Thank you so much. Talon, you get 10,000. Nicole. I was like, where'd that 0 go? I didn't see it appear. So easy to make little mistakes, but so we are going to definitely reject the null. Reject the null because the p-value is low. And we can look at the graphic over here. When we look at the graphic, who is more likely to survive? It's funny, the red is that, but the women were more likely to survive. The women were more likely to survive. Let's go here to color theme. Let's go with that, divergent. Oh, whoa, cool. Oh, it's still black, there we go. Why is the p-value 0? Here, I'll show it right here. What we have going on with this p-value is, and I'll answer a few more questions, let me answer that. So we're gonna reject the null. There is strong evidence that females were more likely to survive. Yeah, we got it. Okay, so let's talk about why the p-value is basically 0. The p-value is 0 on the, or at least on the homework, what I would suggest doing is knowing that we're using the chi-square distribution. I want everyone to practice. This is a good one right here. I want to know, Brian, this is a what by what. I want to see it in the chat for 10,000 points. You have to say, Brian, that is a blank by blank matrix. Be careful, there's a trick to this. Brian, that is a blank by blank matrix. Be careful. Nice job in the chat. There you go. And Adrian, another 10,000. Thank you for the answers. Brian, that is a 2 by 2 matrix. Nicole, another 10,000 right there for the extra wording. Brian, that is a 2 by 2. Now, what are we practicing right now? We're finding the degrees of freedom. To find the degrees of freedom, what do? We simply take each of our fingers and we drop it by 1. And now we get 1 times 1. The degrees of freedom formula is row times 1 times columns minus 1. Well, there's 2 rows to that, and there's 2 columns. So we did minus 1 off of each one of those, and we get 1 times 1 equals 1 degree of freedom for that. You can also see this visually. If we go over here to Word, we can actually draw this out by deleting a row and deleting a column. Go all the way back in time right here. And if we delete a row and delete a column, you can see this. Let's go right here. Oh, we'll do black. Delete a row, delete a column, and you're left with 1 degree of freedom. We have 1 degree of freedom, which you will also see in the jump output. Just to be clear, that tells us what chi-squared we are using. We now know this is a chi-squared with 1 degree of freedom, and we have confirmed it. Do not use the totals. Do not use the totals. Those are not levels to the variables. They'll always be totals. Those are not used. So, and Adriana, you get 100,000. Huge help right there, explaining all the concepts, because that's what's going to happen next is we're going to take this and we're going to bring it over and we are going to go to a chi-squared distribution. So we're going to use Matt Bogner's again. He just does such a great job with these applets. So I'll drop it in the chat too. So here is the Matt Bogner applet for chi-squared. Oh no, I'm between screens. There we go. Really? Okay. Let's put that in the chat. There we go. There's the Matt Bogner chi-squared applet. And now we go here and we go to the degrees of freedom 1. And I want you to think where we're at. We are over at 600. We are at the right of 630. So we are off this grid. So our chi-squared is 630. So we're going to plot the area above 630.02 apparently. My Pearson wants that 0.02 in there. And the answer is 0. If we were to plot the area above 1, we're actually going to be able to see it, or the area above 2, we can kind of see it. The p-value on this is the area above the chi-squared test statistic we find. And you need to know the degrees of freedom because that changes the way the chi-squared curve looks. So if we had like 3 degrees of freedom, what kind of matrix could result in a 3 degrees of freedom? Oh, cheat, do something really easy. A blank by blank would have 3 degrees of freedom. A blank by blank would have 3 degrees of freedom. I think there's only a few answers, or only one I can think of. A blank by blank matrix. So you have to think, I have to hold up this many fingers and this many fingers and then drop them 1. 4 by 2, Taven, 10,000 points. 4 by 2. 6 by 6 would have 25 degrees of freedom. A 6 by 6 would have 25. A 2 by 4 or a 4 by 2 would have 3 degrees of freedom. Reason being, 4 by 2, hold up your fingers, drop them, and then you have 3 times 1. We're just doing the formula here by figuring out a 4 by 2 would have 3 degrees of freedom. 4 by 2, 3 degrees of freedom, because you multiply these two numbers. You multiply 3 and 1. And then if you had 6 times 6, that math is too complex. I'm sorry. We'll go back to just doing addition. No more multiplication. And so, great question right there. Adrian, did that help with answering the chi-squared stuff? Does it make a little more sense on how to do it in jump? Do you feel like you can maybe do the other chi-squared questions in jump? How we doing? Let's go for another 10, 15 minutes. I'm going to try to do some reviews on Friday. No more math. We'll try to do as little as possible. Who has questions? You ask the questions, I give the answers. What do we have? Do we still have some people in here from other sections? How are people doing? It is evening on the last day of class. My gosh. Last day of class. I feel like, I wonder if I could I want to turn off the green screen and do like a behind the scenes. No, we lost people, no. 37. Do we have to do it in jump? You don't have to do it in jump. Here's the biggest thing though, please realize this. One, know how to read jump output. I'll talk about the test here a little bit. I'll be doing more talking about the test, but here's some stuff to know. Morgan, great question. You should know that if I had 45, 99, 151, and 332, that would add up to what? Who can do that in their head? 45 plus 99 plus 151 plus 332 would equal up to what? And teach to the test, like that. That would add up to 630.018. How did I know that? I know that because the cell chi-squareds summed together give you the Pearson chi-squared test statistic. So these cell chi-squareds added together equal the Pearson chi-squared test statistic. I also know the 4 steps for this. Step 1, write your null and alternative. Step 2, find your chi-squared test statistic and check your conditions. Step 3, find the p-value. Step 4, reject or fail to reject the null. If you notice, every single one of them is the same. You don't have to memorize the 4 steps, but you'll see them throughout the test. You'll see things being like, what is the t statistic? All these things are kind of a lot of things we've been doing repetitively. Will we be giving charts for chi-squared on the exam? Nope, no charts. We might ask you to tell us things about the chi-squared. We don't usually have you do the p-values. We might just give you the output. Rarely, at least as you can see, we don't, in statistics, ever really find it by hand. So we try to do it in a more modern method where we give you the p-value and we're like, would you reject the null? And the answer is definitely. That p-value here is ridiculously low. How many? It's e to the negative what? If you hover over it, you can see the p-value. And it's e to the negative 139. That's 0.00001039. It's ridiculous. It's tiny. So if you find the chi-squared, remember it's observed minus expected squared over expected. That is a cell chi-squared. Great questions. Keep asking those questions. I think I'm looking. Take a few more questions. We're going to definitely do. I'm gonna take those test videos I did and put them as individual videos. Maybe I'll do it tomorrow during study day, but keep asking those questions. I should crack open one of those Red Bulls, Eric. Should we go for another 10, 15? Or are you guys thinking chat is so quiet? Do you want to do a chapter 17 question? That's good. We haven't done one of those today. And you know what, Adriana? Amazing way to end the class, because if we do a chapter 17 question, I think Eric's got the right idea. There we go. We're going Red Bull mode right here. We're good to go now. We're Red Bulled up. Are my arms like it's pale? ASMR. Oh, because you got cracking me up. Oh no, I'm gonna cough now. Wait, we gotta cough. Oh yeah, we're good. God. All right, let's do a chapter 17 question. We got our Red Bull. We're good to go. You know, regular Red Bull's good, but coconut Red Bull, you'll never thought it. You never think you'd. It's just amazing. One of my students was telling me today, they said, I bought a coconut Red Bull just to try it, and now I'm hooked. And I was like, it's good stuff. Oh no, Serena, it's too funny. You guys are cracking me up in the chat. It's funny, like everything I hear, I realize you guys can hear too. And I'm a bad influence. Don't drink Red Bull. Now Red Bull's not going to sponsor us. We'll never get that Red Bull sponsorship. I went to their site and they said we're not doing sponsorships, and I got really sad. And then I drank more Red Bull and I got happy again. So please sponsor us, Red Bull. Okay, which question are we going to do right here? Which question are we going to do? Oh no, Nicole, no. We need that. We need Red Bull to hear that though. We need Red Bull. Sorry. Sorry, UT. I don't know, maybe you're an influencer. Oh my gosh. Okay. You guys, let me just say this. Like, teaching this class has been so much fun, and being able to stream it and being able to, being able to like actually, it feels, sometimes you can be in front of a class and it's like those days we have like, and that's all right. We'll get down to like, people been in here on the days when we have like 5 or 6 people watching. It's always a little harder to get the energy going up, but you guys, even when there's like 10, 20, 30 people in here and we got some chat going, it really helps. The second part of this question, this is the comparing. Do we need to do the chi-square without jump? Not yes and no. Please, the practice test is a great example, Eric. Amazing question, Eric. The practice test has some really great stuff. Do you guys want to see this question, or is there a different one? Do you guys want to see this question, or is there a different one? We can do this question, different one. You guys name it. I'll do one more question here. You guys name the question. You tell me. Say, Brian, do the question that has such and such, and we'll do it. We'll do a chapter 16 for this. Why not? We put the data in jump. Let's do that. Is that the children's cereal one? The children's cereal one? I've got a video on it, but it's a really good one because on the test, do it instead of yeah, it's technically right. Yeah. It's the same, and I'll explain. Let me explain real briefly. Adriana asked a really great question, then we're going to answer the other questions too. It is mathematically the same. Oh, we don't want highlighter on that. Go away. The null being mu1 minus mu2, that is what you're testing, and that's the hypothesized value. But you could write it alternatively if you mix up the writing, which is, it's technically correct. If you mix it up, you can write it as the null being, and I'm just writing a different way of writing the null, mu1 equals mu2. But the reason being, usually we write it in 3 parts, where this is part 1, the null has the equal sign in part 2, and this is part 3. This is not the hypothesized value. I guess you could technically say you're hypothesizing that mu1 is equal to mu2, but in truth, you're testing the difference, which is part 1. You're testing the difference and hypothesizing that the difference is equal to 0. So it's more kind of structurally accurate to do it in the blue way, but it is mathematically equivalent to do it in the red way, which mathematical equivalent, tomato, tomato. But speaking of it, we would say that the difference between the 2 means is equal to 0, which means when you say the difference between the 2 means, according to the null, is equal to 0, and the true means technically, then you're saying that there is no difference between them, i.e. they're equal to each other according to the null hypothesis. So yeah, it should be correct, and I'll make sure when I'm helping out the keys that we try to make that as clear as possible. If there is right and null and alternative for the 2 means. Yep. A good way right there. And then the serial one, yeah, let's do the serial one. It's really good. I like the serial one. I'll explain why. The serial one is really excellent because it has output in it. And we do like to put a lot of output on the test. We like to say, analyze this jump output. So let's do the serial one. Where's that darn serial one? Is this the serial one? Oh, this is the route one. We don't want to do the route one. Is this the serial one? Yes, it's the serial question. Let's do the serial question. Let's get some. I got new cereals, like God. Any sort of cereal that's got like sugar in it, I like. And you see that in this question. Let's copy these numbers to the clipboard. Copied to the clipboard. With these numbers copied to the clipboard, you got it. We're doing a new jump sheet. Now, when we paste data into jump, what do we got to do? Every time we paste data into jump, we got to make sure we paste it in correctly. We paste it in. So let's take the data and bring it over here and paste that data in. Please tell me, is my data pasted correctly or wrong? Is that data pasted correct? Taven's already got it right there. Taven knows how to paste the data. She is correct. That is wrong. No, oh, we will stack it in a second. Oh, I'm gonna click the wrong button. You guys know how to do this one. I like the no in the chat. Now we're good. And now we're gonna go over here and go to tables, stack, double click, click OK, and we're good. Please notice something. What do we have right here? We have a categorical variable and we have a quantitative variable. Categorical, quantitative. This is the essence of the two sample t. The two sample t is when we have one categorical and one quantitative variable, and we want to see if there's a difference between the two means. Wait, I'm so confused. I think we're good, right? Did I miss something? I think we're good. Let's go here and do the two sample t-test. Fit y by x. We're going to put a categorical variable in the x and a quantitative variable in the y. We got it. I want you to look at this right here. I want you to look at the values, and I want you to tell me, does it look like children's cereal has more sugar than the adult cereals? This is the amount of sugar it had in it. Probably shouldn't go below 0, so let's move that line. Down here is like Wheat Thins, or not even Wheat Thins, but like Fiber One, horrible. And up here is like Oops All Berries. In the middle here is something like Captain Crunch. Here's Captain Crunch with berries. I guess that starts to go to a kid's cereal now. Captain Crunch is probably over here. I don't know. It's kids, so I guess over here. But yeah, probably. I hope that's the Fiber One right there. No Fiber One. And so now we're good. We're going to go right here, and guess what we're going to do? We're going to do t-test. This is a two-sample t-test. I know it says t-test. It's a two-sample t-test. And now take a look. Guess what? We're going to bring this jump output over, and we're going to talk about the jump output. I need to splice this video here and be like, talking about jump output. Let's talk about the jump output. Boom, jump output. Red Bull up, get ready to go. Brain flakes. Okay, so what do we got in this jump output? Here's a trick. A trick we can do is we can write mu in blue. We can write mu, and look what we've done. Guess what we just wrote out right there? We just wrote out the what right there. Now in coconut flavor. We just wrote out the what right there. What did we write? By just writing mu children's cereal minus mu adult cereal equals 0, I wrote the what? There we go. Null hypothesis written with the output helping us out. Now, the question might ask us things like, are they equal? Are they not equal? We would have to pick, and for that, we'll have to pick the sign. These signs would go into here, and the first one is the does not equals, the greater than, and the less than. Such that as if you picked this right here, you'd be saying that the difference between these two means is greater than 0. Now, if you're using the greater than alternative, which of the two is bigger? If you're using the greater than alternative, it would be the first one. Think about this. Just do some imaginary numbers. This one right here is imaginarily, let's just say, 50. And this one is 15. Is that a positive or negative number when you use imaginary numbers? 50 minus 15 is what? And these are imaginary fake numbers I'm using. It's positive, and that means the children's cereal is bigger. And I want you to notice something right here. The difference is this value between these two numbers. The difference is what we would get when we do y. I've got so much on the screen. Let me clear up the screen a little bit. Okay, cool. The difference would be, and let's circle that to make it clear. This difference right here is found via the formula y bar 1 minus y bar 2. That difference right here. Oh. Calzone Tyrone. I want to know from the chat, how much extra credit does Calzone Tyrone get? You are a fan favorite. People even talked about you during our interviews. We did some interviews about this class. You are a fan favorite. How much extra credit should we give Calzone Tyrone? 1 billion extra credit to Calzone Tyrone. It only maxes out. He gets, there you go. Calzone Tyrone, you are fan favorite. So good to have you. You are free to come in anytime. Favorite of all. Thank you very much. We'll be doing another Kahoot probably on Saturday, Calzone. So check it out. We'll be doing another Kahoot. What do we see right here? We have the standard error of the difference. I'm going to erase a little bit of my handwriting here. So does everyone see this is the difference? The difference is that formula. Here's the standard error of the difference. The standard error of the difference is the following formula. It is S sub 1 squared over n sub 1 plus S sub 2 squared over n sub 2. If you notice everything I've written out, good job, Eric. Eric, you get 100,000 for that right there. So what we have right here, what does this do if you take these two numbers and you divide them? I want you to look at these two things I've highlighted, the difference and the standard error. If we merely just take, and man, I wish if I got better at this, I could select. Oh no, that would have been so cool. It's highlighting it. That's such a bummer. Darn. If I take that difference right there and I do this, y bar 1 minus y bar 2, oh my gosh. When we did the interviews, people were like, whoa, these lights are bright. Yep, they're bright. Y bar 1 minus y bar 2, and they're saying in the chat, you know that solves for the t statistic. So guess what? These two numbers right here, one of my favorite things we've ever done on the test is we blank out this right here. We blank that out, and to solve for that number, all you have to do is divide these two numbers. These two numbers right here that I'm circling is the formula right here. And that formula equals t, which is the value right there. Does that help make sense of this output? The difference is what you saw in the sample. If someone asked you to interpret the difference, it would be children's cereal in the sample had 35.57 more grams of sugar than the adult cereal. Let me repeat that. The interpretation of the difference is the children's cereal in the sample had 35.57 more grams of sugar than the adult cereal. The standard error is a measure of variation in the samples. It's kind of like standard deviation. You can see it right there in the formula, but it's a measure of the variation. Now we get to the confidence interval. You know what's really interesting? I want people to calculate what is about the margin of error for this confidence interval. What is the margin of error for this confidence interval? Who here can tell me for 100,000 points? We're near the end, and I'm throwing out some mega points. Who can tell me what the margin of error is for that confidence interval? You don't have to be exact. I want kind of an idea of how to get the margin of error. Because when you do the margin of error, the formula is y bar 1 minus y bar 2 plus or minus t with degrees of freedom via a complicated formula, square root s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. Now, well, 8, I know where you're getting 8 from. I see where you got 8. Now be careful. This t right here, that t is not that t. Those two t's are very different. Those are not the same. Let's put not the same. Those are not the same t's. Nicole, amazing job. And Serena, great job. They are correct. Got the 100,000 right there, and so is Rana. Great job. Really tough question. Go to the confidence interval. And this was a question that caught many people on the last test. To find the margin of error, what do we do to the confidence interval? To find the margin of error, what can we do to our confidence interval? To find the margin of error, I see it in the chat. We can take half the length of the confidence interval. So we can go here and take 39.8327 minus 31.3073 minus 2, and that's the answer people are getting. And if I had to guess, I would have said it's about 4.22. And I'm going to tell you why I would have guessed this in a moment. But if you're wondering, how am I doing this formula? I want you to solve for a margin of error together right now. Oh, and then be careful. Nicole, great answer. I'm throwing you 10,000. If you add them together and divide by 2, you'll get the difference. Think of this, 31 and 39 added together divided by 2 equals 35, because you'd get the center of the interval. If you add them together and divide by 2, you get the center. If you subtract them and divide by 2, you get half the length of the interval. Try this out. Let's do our simple questions to practice. And you can do this on the test to see if you remember. we're gonna get some Chick-fil-A and it'll cost between $4 to $10. What is the estimate? We're gonna get some Chick-fil-A and it'll cost between $4 to $10. What do you think it's gonna cost? What is your best guess of the cost? We're gonna get some Chick-fil-A and it'll cost between $4 to $10. I should have said Taco Bell. So what is the estimate? Careful, I know which one you're doing. I tricked you, I went the other way. You're doing it, you're getting the margin of error. But the estimate, what would be the estimate? Wait, between $4 to $10, between 4 to 10. I did a trick, I switched the question. Instead of margin of error, I said estimate. You are right, Adriana, another 10,000 right there. It is 7. Now, what is the margin of error? 7 would be the estimate, which is the center of the interval. And then 3, as people are saying in the chat, would be the margin of error. Does that make sense? Because what do you do to get the estimate? The estimate is at the center of the interval. This is the estimate. Please tell me, where do you see that in the output? Where do you see that in the output? Where's y bar 1 minus y bar 2? That's the estimate of something. It's 50 cents. Nicole, you get 10,000 right there. $15. Where do you see the estimate? That's the center of the interval, that's the estimate. Chick-fil-A's, when I was in school, oh no, I'm sounding old now. A Chick-fil-A sandwich was like $2. You are right, Taven, nice answer in the chat. That is the center of the interval right there. And then you have to solve for the upper and the lower. The difference right here is this right here. This plus or minus is the difference from that value. So does that make sense what I'm drawing out right there? That difference right there is that full equation, that t times that. So this is crazy, but remember you just said that the margin of error is basically 4, and I'm gonna highlight something else right now. Where is, oh my gosh, there we go. Where is this in the interval? Where is this? Right here. Does anyone know what the value of t is that made the interval? The value of t, if the margin of error is 4 and the standard error is 2, who knows what the value of t was about? The value of t that made this interval was basically what? And here's your hint. It's a 95% confidence interval. It's a 95% confidence interval. The value of t is very close to, and it doesn't have to be close to this because it's a t interval. The value of t is basically, for 100,000 points, nope, no one got it yet. No one's saying the value. No. So wait, this long pause here. I don't want to say I don't want someone to get it. I want, think of this. Let me make this very clear. This value right here, Taven, nice job, you got it, it's 2. Because this is basically 2 times 2, and you said the margin of error was equal to 4. Because remember, it's plus or minus 4, and this is basically 35.5 plus or minus 4. Does that make sense? And what was I doing right here? What was I doing with this? I was going, 68, 95. A 95% confidence interval usually has a t or a z close to 1.96 or 2. The z is 1.96, or more specifically 1.95999. 2 nines, not 3. But the 95% confidence interval is a z-score of 2 or 1.96, and the t is usually very close to that depending on large enough degrees of freedom. These degrees of freedom are slightly high, so it's probably about 2.05, and you would have to use that in a t-applet to find it. Nice job in the chat. Thank you, 10,000 points, all those answers. But that covers pretty much this whole output. This is the level of confidence. We can figure out the center of the interval, the margin of error, and we can even do the t-test. Please note, while doing this output, I did things like write out the t-test. I did things like write out the confidence interval. The degrees of freedom are a complicated formula that we will not have you solve. It's in the other video, but we'll never have you solve this. But what does the degrees of freedom tell you? The degrees of freedom tell you what t distribution you are using. That t curve right there is a t with 45.2 degrees of freedom. And then go over the 2 different t's. The 2 sample t and the 1 sample t, is that the question, Eric? The 2 sample t and the 1 sample t? I'll do that next year if that's the question. And so now the last but not least thing is that this p-value right here is the area below this line. So if you go right here and you go below the line, you would be shading in 100% of the area, because it'd be all the area below the line. That's 100%. Next, we would do the area above the line, and the area above the line has a very small p-value, meaning we could reject the null for the greater than test. So here's the area above. Please note how this is above right here. So you would go above and shade to the right, because the arrow points to the right. And so we would shade above, and there's no area above that. And last but not least, we would shade the two-tailed test. And the two-tailed test means we need to reflect our result. So we reflect it on the other side, and we shade outside of it, and there's no area. And so it's basically reject the null for the two-tailed test and reject the null for the greater than test. We wouldn't pick the alternative here. We would choose that at the start with our null and alternative, and we would do that. Does that help with all of this output? And Eric, you want me to go over the two different T's, as in the one sample T and the two sample T? The C level T and the other T. The C level, are you talking, I think I know what you mean. Do you want to talk about the T that is used for the test and the T that is used for a confidence interval? I think that's what you're talking about. The T that is used for a test and the T that is used for a confidence interval. So that's a really good question that I've seen a lot of people mix up. When you do a confidence interval, let's write a one sample T confidence interval. We have here y bar plus or minus T with n minus 1 degrees of freedom, S over square root of n. We put a star on this, meaning you get to pick it. Then we have, and let's write over here, confidence interval. Then we have right here, we have y bar 1, oops, 102 the two sample, what am I doing? Oh no. We have right here y bar minus mu naught over S over square root of n. This equals to a T with n minus 1 degrees of freedom. This is a test. Now, when you do the test, the T that you get right here, you are not going to be picking. This test is a difference between your sample mean and a hypothesized mean standardized right here. It's just a difference standardized, and that gives you a test statistic right there. But when you get this confidence interval up above, you get to pick this T. And the T you pick right here is based on the what for this interval. What is this going to be right here? What this T we pick is based on the what for our interval. This T is based on our level of what. That T will be assigned based on your level of what for the interval. That T is assigned based on your level of what for the interval. That T is assigned based on your level of something. Level of confidence, that's it right there. Your level of confidence, you could pick a 95% confidence interval, a 99% confidence interval, a 98% confidence interval, an 80% confidence interval. That T is based on your confidence level. Now you can use confidence intervals to do tests. So you can say like, oh, this would be the same as doing a two-tailed test, because when you talk about the way confidence intervals work and tests work, well, a confidence interval looks like this. And that's a confidence interval right there because it's got the inside shaded. And then a test looks like this. So if you were to pick a 98% confidence interval, that'd be the same as using an alpha of 2%. So it is true that the confidence level you pick has an associated alpha level for a test. And that's an important concept, how tests and confidence intervals have a relationship. But you can pick that T, you can make it whatever you want, and that'll assign the confidence to the interval. Down here, you do not pick this T. This T right here, you do not pick. That is the T that you find via the difference between the null and the sample mean. And that's just the difference over there you see on this part of the equation. The difference between your sample mean and the null, and what do? You standardize that difference to get a test statistic, and from there you find a p-value. Only in the test do you find a p-value. With the confidence interval, you can technically use it to find a p-value, but you don't have to. I mean, not a p-value, you can use it to reject or fail to reject in a confidence interval. Does that help a little bit more explain the difference between a t confidence interval and a t-test. The t-test is a difference standardized, and the t-interval is an interval to estimate what the true mean might be. So a little bit different right there, just difference between the confidence interval and the test. Very similar notation, and they can mechanically do the same things. I think that's where some of the confusion is. Let's take another question or two, and then we'll head on out. Any other last few questions? I'll send out, we're gonna do reviews on Friday and on Saturday, it looks like, and you guys get to ask all the questions. Thank you guys so much for being here again. I never thought, it's so weird. I think many people at the start of the semester were like, wait, we're not having a physical classroom. Wait, we're not actually going to be like, because in the past, oh, you guys are the best. Yeah, this has been the craziest, funnest class to teach ever. Everyone who was talking to us was like, we want more of this. We like where this is. We like what you're doing. And please fill out the TN Voice. I'll send out a reminder tonight. Probably everyone who's here right now has filled out TN Voice. But, if you didn't like it, you still fill out the TN Voice. But I really, really like this, and it's awesome. So with that, Eric, for you, we did this last time, but you weren't here. I still got the button. This button stays. I'm gonna press it. I'm gonna knock over stuff, and I'm gonna press it. We gotta end strong. We're gonna end, as we always do, with Kahoot Sack. See you guys next time. See you on Friday and Saturday. We're back. I saw it. Eric, do you want some chapter 16? That's a fake out right there. We probably lost everybody. I took off the mic. Is Eric still here? Are you still here, Eric? I think it's chapter 16 question, right? It's a fake out. We're back. All right, wait. Here we go. Let's look at chapter 16 real quick. You ready? Let's do it. The exam is Monday at 12:30. I'm 99% certain about that. I'm always afraid to say the times off the top of my head. Elizabeth, double check, but that does look to be correct. We're back. Let's do a chapter 16. I remember you saying that earlier. Let's do a chapter 16. Is there a specific one you want me to do, Eric? Is there a specific one you want me to do here, Eric? Which specific one do you want me to do? Is there like the one about what? Just be like the one about this, or I like these nulls and alternative ones. Oh no, I'm sorry. There's some obvious wrong answers right here. The wrong answers are going to be things like X bar, P hat. Those are wrong. So we want to see the wins on a casino machine. They say it's 5 out of 10. I want you to think about this. You either win, we'll do a quiz one here next. So you either win or you don't win at a casino machine. That makes it the proportion. So the proportion, and we would have that it's equal to that. And they want to see if it is that, so we would do this right here, if it's equal or not equal. Check answer. Cool. Let's do a quiz one. What quiz one do you want to do? Chapter 16 quiz. Quiz. Okay. This one right here. Which one we got? Do this one. What type of error is made when a false null is not rejected? That's type 2. The null is false and we fail to reject it. Type 2. We're good, right? Right, Eric? We're good? All right. Oh, yeah. Oh, this is a fun one. Oh, yeah. We'll do this one. You ready? Let's do a type 1, type 2 error one. We'll finish with this. We got this. Okay, here we go. Okay. A company is sued for discrimination because only 23% of newly hired candidates were women when 47% of the applicants were women. Is this strong evidence that the company is hiring practices are discriminatory? Let's do it. Thank you, guys. I like helping you guys out. If you guys are learning, I want to help out as much as I can. Is this a 1 or 2-tailed test? So what do we got going on right here? It's going to be 1-tailed because they're trying to show evidence of discrimination. It's going to say that they're not going to get sued if there's not, like if they're like you hired too many. So they're trying to show discrimination. So it's a 1-tailed test because they're only looking in one direction. They're trying to see too many were hired. Wait, They wouldn't be sued if too many hired. It's a one-tailed test. And that means they're trying to see they hired too few, like too little. What is a type 1 error? So think about this. The null would be not discrimination. Like in a court case, you start out not guilty. So if the null is not discrimination, in a type 1, the null is true. So say it out loud. The company is not discriminating. So if we make a type 1 error, the company is not discriminating and they're found to be discriminating. So a type 1 error is decided that the company is discriminating when in fact it is not. Only a few of these can be an error because if they're decided they're discriminating when it is, that's the right thing. If the company is discriminating, we should find that they're discriminating. In the context, what is a type 2 error? The null is false. So it is false that the company is not discriminating. So the company is discriminating, and did I just reverse it? I hope I didn't. Yeah, there we go. Is deciding that the company is not discriminating when it is. So the null is false. The company is discriminating. It is false that they're not discriminating. The way they word these might be hard. You just have to think, in a type 2 error, we fail to reject the false null. So it is false that the company is not discriminating. So the company is discriminating, but we're going to fail to reject that. It's very tricky. Write it down. You have to practice these things. You have to say, in a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. You have to practice saying it and you have to make sure it makes sense and you have to write it down. What is the power of the test? The power of the test is the ability to find that the company is discriminating when they actually are. So the power of the test is to correctly figure out when they are discriminating. The power of the test is the ability to reject the false null. So if the null is false, we should be able to reject and figure out if the company is discriminating. So the power is figuring out if the company is discriminating. Ooh, these trick me up sometimes just because the way they word increase, decrease. So what we're doing right here is we're going to, if the hypothesis test is done at the 0.10 alpha level instead of 0.05. So I want you to think what we did here. If it's done at 0.10 instead of 0.05, what have we done? We have increased alpha. And if you increase alpha, you increase the power. The power of the test will increase because the level of significance has increased. The lawsuit is based on 41 employees. Is the power of the test more or less if it was based on 17? So is 41 more or less than 17 in power? The power of the test is higher because the sample size increases. I think I did everything correct. Woo! Got scared there. Yes. Did that help out, Eric? Talking about these higher power, larger sample size, higher power, larger alpha. And if you look at that right here, they're literally covering alpha right here, and they're covering sample size. They can't really control the effect size. The effect size would be the difference up here. Like if they only hired men, then that would be a larger effect. It'd be easier to notice a company that only hires men versus a company that kind of discriminates a little bit. Does that make sense what the effect size would be? The effect size would be, a large effect size is a company that only hires men, and a small effect size would be a company that just barely is not hiring women. So that's like the effect size right there with this hypothetical problem. So that would be the effect size. Did that get it all? Thank you so much, and I appreciate you guys. We're gonna head on out now. Should we do one more crab rave? You're like, we need new animations, we need new stuff. Jason! Let's do it. There we go. Cool. Have a great evening, everyone. Thank you guys so much. Keep working away, keep studying hard, and I will see you guys soon.